Good afternoon. I'd like to tell you about the intelligent cloud. But first, let me tell you a story. Before the cloud, there was a sky server, to be precise. Now, what's the world's largest telescope? Many people will answer Keck or Hubble. But the world's largest telescope is not made with glass and mirrors, but it's made of a database, SQL Server. It's the Sloan Digital Sky Survey, a massive survey that mapped the universe and saved its data to SQL Server databases. For the very first time, we had the richest catalog of objects in the universe and their spectral properties, all searchable, queryable, and analyzable by not just scientists, but all of us all over the world on the web. It had a rich treasure trove of objects in our universe, globular clusters of stars, galaxies of all sizes and shapes, gas clouds light years in length, remnants of exploded stars called supernovae, black holes, unfathomable objects like quasars. And they had all of this in a database that you could literally fly through. And astronomers of today fly through the universe using the language of SQL. And let me show you a fly through like this time a real video. That was not made by Hollywood. That's from the Sloan Digital Sky Survey. And everything that you saw in there was a real object in the universe somewhere. Now, SQL Server was at the heart of it all. When astronomers did the survey, they needed a database, a very powerful database, to index and query all of that data, 150 terabytes of images, and make it accessible over the web to the rest of the world. And they chose SQL Server. And Sky Server, built on SQL Server, is the world's most used astronomy facility today. There have been over 280 million SQL queries run on it, over 5,000 astronomy papers published, has been cited over 200,000 times. It also democratized astronomical discovery and led to the emergence of the citizen scientist. Anyone online could explore the universe and discover amazing things never before seen through Sky Server. So, SQL Server, which was behind it all, is today one of the best databases on the planet. It is capable of supporting 12 terabytes of main memory. It's the best single-node data warehouse according to benchmarks. It can be deployed anywhere. It runs on Linux and Windows. It can hold any type of data. You can even connect to Hadoop systems for unstructured data. You can store JSON documents in it. It integrates, for the first time, machine learning and advanced analytics deep into the database. Now, by the way, folks, this is actually an important innovation. Now, just as database management systems changed the management of data and freed the application tier from having to do all of that hard work of indexing and storage and doing query processing, and relegated all of that to a management system for data. What we have now done is brought that same capability to advanced analytics and machine learning. So instead of the application tier doing all of the hard work of variables, computation, and data joins, and managing machine learning models, they can be managed in the database the same way as data in a secure fashion. And now, it becomes a property of the enterprise itself and not locked up in an application somewhere. And that machine learning model and advanced analytics can be shared among multiple applications. That's a big step change in how intelligent applications are built. And such applications can now be built with any language, Java, .NET, Ruby, Python, you name it, all of that supported. So SQL Server then becomes truly a platform for data-driven intelligence. One more. We believe the future of analytics will be centered on the open source R language. Microsoft R Server is a cross-platform, enterprise-grade, scalable implementation of analytical functions in R for a variety of platforms. For SQL, for Hadoop, it's cross-platform, it's Linux, it's Windows, and runs on-prem and on the cloud. We even offer a free R client for data scientists for development purposes. All works well with big data systems and databases. And now SQL Server on Linux is under private preview. We've had immense interest from customers. Over 15,000 people signed up from all over the world for the private preview. Over 54% of Fortune 500 customers are interested in doing that private preview with us. So to show you a little bit of the magic of all of that SQL Server, I'd like to show you a demo. We are going to use the Sloan Digital Sky Survey dataset and show you a few queries that run blazingly fast on this. Let me invite Tobias Tornstrom, who is the GPM of SQL Server on Linux, to show us this demo. Tobias?
Hey, Joseph.
Thanks.
Here you go.
Oh, thank you.
Hello, everyone. So I wanted to take a look at this Sloan Digital Sky Survey that Joseph talked about. And it's quite amazing. I was literally blown away when Joseph showed it to me. And I actually been exploring the universe a little bit with my kids. Might have told them that their dad works with exploring the universe.
It's a bit easier way to explain us what software engineers do.
Exactly.
Yeah.
Exactly. So first of all, let's take a look at something that might be interesting to us, which is find objects that are moving fast towards us. So most of the objects in the universe are moving away from us or away from each other, but some of them are moving towards us. So I'm going to go here to search in the application and say I want to find blue-shifted objects, which is what these objects are called. And I hit search, and in 2 seconds, this came back. And let me just click on the stats up here. So this is pretty amazing. In just about 2 seconds, we queried 1.2 million rows, 509 columns. That's over 600 billion data objects, and returned the top 10 objects that were coming towards us fast.
So it's about 1.2 billion objects, and there isn't really sort of a column that says it's a blue-shifted object. It has to be calculated, right?
Exactly. Right. So actually, let's just take a look at the query that we ran. So this is the query that ran to actually explore the universe and find these objects. So we have some mathematical calculations here to figure this out. And that's the object that ran against a table of, this one is about 5 terabytes in size.
Yeah. So analyze about 5 terabytes of data in 2 seconds to find blue-shifted objects.
Exactly.
Coming straight at us. Great.
So let's take a look at one of these objects. This is a galaxy Messier 90. And let me click that. If it were.
Yeah. I think that's that.
Oh, I already zoomed
you
into
already
it.
have it. Yeah.
My bad. OK, so let me just right-click that then. So what happened now is we queried the database and brought up a history of objects, of information about this object, about this galaxy. And so I can click on, for example, this one here, and it shows me the information about this particular instance of information about this galaxy. Now, if you look at this location column to the right, you see some of these objects look kind of like a server, and some of them look like a cloud. And this means that some of the data is actually stored in the database on premises, and the data that's marked with a cloud, those particular rows are stored in the cloud in Azure.
So it's the same database, sort of partly on-premise, partly on the cloud, and the application doesn't have to change.
Exactly.
And still query.
Exactly. It's this single table is stretched, as we call it, between on-premises and cloud. But the application just sends the same query to SQL Server, and then SQL Server's Query Optimizer figures out if it should send a query to Azure or not. So if I click here, I send the query to SQL Server, it just queries locally. And if I click this one, so it took a little bit more time, but then it actually sent the query off from SQL Server to the cloud and brought the data back.
It's great.
So let's take a look at something else which is interesting. So apparently there is this problem in the universe that there is a ton of stuff out there, just an amazing number of objects. And what astronomers want to do is they want to classify galaxies so that you know if it's a spiral galaxy or some other type of galaxy. And the way people have typically done this is that astronomers and citizen scientists look at the picture of the galaxy as well as certain attributes and then basically classify it. But the problem here is that there are so many objects that basically crowdsourcing doesn't really work.
Yeah, it's a few 100 billion objects, so...
Exactly, just a few 100 billion.
Yeah.
So by having R integrated into SQL Server, we can actually use the power of a trained model that's trained based on classification done by users and use that model to classify the galaxies without any other use than actual R. So before I do this, let's just take a look at the query that I'll run. So here you can see it's a regular SQL Server stored procedure, but I say here, please execute this external script, which is an R script, that grabs a list of unclassified galaxies, passes it to R, uses the model that's stored inside SQL Server to classify these galaxies, and return the classified objects back to the application. And from the application's perspective, it's just like running any query. It doesn't have to know that it's actually accessing some other language, such as R in this case. So I'll say I'm going to use a random forest algorithm to classify. And there we see in about 2 seconds, I classified close to 2,000 objects. And we can just group them. So we see here star, elliptical, and spiral galaxies.
That's beautiful. So imagine for a second, instead of galaxies, you had customer data, and you were doing customer segmentation. You could do those machine learning inside of the database and get results like this.
Absolutely.
Okay. So, Tobias, can we install SQL Server on Red Hat Linux?
Absolutely. So you can build an application like this on Red Hat Linux using SQL Server. So let's take a look here. I have a terminal here connected to a Red Hat Enterprise Linux server. And I'm just going to run yum install MS SQL Server. And so when we did this, we obviously want the experience to be exactly what you would expect on Red Hat Enterprise Linux. And we want it to be basically native to the natives. So whatever you would expect on Linux, that's the experience you'll get. So now we just installed SQL Server on Linux. Now the next step is to configure SQL Server to basically set the SA password. So I'll have to accept the license agreement. Ooh. You have to do sudo. So now we're configuring SQL Server, and then the next step is just to start the service. So now it's started, and then let me connect. And I'll run a little query. And there we have it, SQL Server running on Red Hat Enterprise Linux. About 1 minute from starting the installation until we're done, connected, and ran the query. Now, obviously, this isn't everything. There's more to running a database and running an application than just installing it on an operating system. So something else I wanted to show you is this. So here we have an application deployed in OpenShift. And if we take a look at the pod, which is very simple in this case, I just have one thing inside it. But here I have SQL Server installed. So think about this. What you saw is me using a MacBook, using Google Chrome to access the web application, with the database running on SQL Server, inside the Docker container, on Red Hat Enterprise Linux, in this case in Microsoft Azure, managed by OpenShift.
Awesome.
Thank you.
Thank you. And nice hat, by the way.
Thank you.
So Microsoft loves Linux. And we have a number of announcements today. So we have OpenShift. We have support for it. It makes it simple to deploy Red Hat's OpenShift on Red Hat Enterprise Linux on Azure. We are announcing the GA of .NET Core 1.0 and ASP.NET Core 1.0 today, and .NET Core 1.0 support on Red Hat Linux. And we have RHEL also supported in Azure China. And you know what? Over half of all of the VMs today in Azure run, or 1/3 of all VMs in Azure today run Linux. And I also want to tell you a little bit about the scale of Azure, the cloud. It's truly sort of a hyperscale cloud in all of those regions across the globe. There are 32 regions supported by Azure around the world, more than any other major cloud provider. It's also an open cloud. It supports any language. It supports any data. It supports any operating system for any device. And you see all of those applications and platforms that run on that cloud. And it's also the most trusted cloud. About 41 certifications and attestations. That's actually more than Amazon Web Services. And it's also the most comprehensive cloud. This is a table from Gartner talking about the wealth of different things that we support and the emphasis that Microsoft Azure has on these comprehensive features of the modern cloud. So now let me tell you a little bit about the vision of where we are going with all of this. So our vision is of innovation along 3 axes. The axis of the cloud, the axis of data, and the axis of intelligence. So with innovation along the cloud, our goal is to support every platform any developer wants on the cloud, and support in infrastructure as a service, platforms as a service, and software as a service to make development of applications as agile and as fast and as simple as possible for the developer. On the dimension of data, we innovate across the entire spectrum, from relational databases like SQL Server, to NoSQL databases like DocumentDB, to data lakes for analytics, to intelligence and operational analytics in memory, and making all of that secure and trusted and as close to real time as possible. And then finally, the dimension of intelligence, which is perhaps one of the most exciting ones today. Whether it be streaming analytics for real-time intelligence, or our server for deep advanced analytics, or machine learning and cognitive APIs for really advanced intelligence, all of that is also supported on the cloud, either as fully managed services or as hosted APIs in the cloud. And we believe the future of enterprises are going to be at the corner of that cube, all in the cloud, using all of the power of the different database platforms and leveraging all of that intelligence to have the intelligent enterprise of the future. So when you surround all of that with open data, with open source, with open competitions hosted in the cloud, and open science, then you get a platform for the future in which every enterprise can build their own future. Let me tell you about our platform, a suite that we have. So we bring all of this, cloud, data, and intelligence together in Microsoft's Cortana Intelligence Suite. It packages over 14 cloud services to help you build intelligent applications. It has components for information management, for big data and data warehousing, for Hadoop and machine learning, for visualization, even a framework for building chatbots, a bot framework. And it's all integrated with Cortana, the personal digital assistant. So imagine then the simplicity of having all of this power as fully managed services in one cloud, so you can very easily glue these things together into powerful applications. And when you have such platforms and an open cloud, it also opens up a number of other possibilities, such as harnessing the great power of crowdsourcing. Here's an example. So we are hosting a machine learning competition today. It is based on data from the Gates Foundation on women's health. This is a machine learning competition to predict the probability of health risks, such as HIV infections, in poor, undeveloped parts of the world for women. And what's great about this competition, the way it's hosted, is it's all in the cloud. The data is open. You can use the platforms right there in the cloud to build those predictive applications, and you can actually deploy web services live that can go into an application that somebody can use in the world to make the lives of those women better. All of you can participate. Just go to that URL. It's an opportunity to make an unreasonable difference to people with algorithms, with cloud and data. And let me share one other really interesting aspect as well. Today, on the cloud, there is a wealth of intelligent APIs. They may be for face detection, for speech recognition, translation, OCR, sentiment analysis. There are about 35 different ones. And what's powerful about it is it's all hosted APIs that developers can very easily glue together into some extremely powerful intelligent applications. The best way for me to show that to you is through a real application. Let me play a video.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
It's a small example of how the intelligent cloud can transform lives. So in 1769, James Watt invented the steam engine. The industrial revolution that followed transformed the face of humanity. The steam engine of today is the intelligent cloud. It's built on open source, open data, open innovation, and intelligent APIs. With the power of big data and machine learning, it will help create adaptive, constantly learning systems that automate everything around us. Posterity will look upon the next few decades as a time of the intelligence revolution. Thank you.